Poi spinning is a performance art which consists of twirling masses called poi on taut strings. From a physics perspective, they're incredibly interesting. My name is Alan Sadoun, and for my final project in 8223, Classical Mechanics 2, I examine an aspect of the motion of poi. When a beginner picks up a poi, they generally start spinning it by rotating in their hand in a small circle, like so. Note that even a small motion of the hand quickly gets the poi to follow suit, and that the poi's rotation about the hand is in phase with the hand's rotation about the center of the circle. When I move the hand right here, to the left, or to the left, the poi is also to the left. However, this phase shift of 0 is not necessary. There's another motion in which the poi and the hand move at a phase with a phase shift of 180 degrees. Note that in this case, the center of rotation is actually in the middle of the poi string because the hand and poi are at opposite ends of the rotation. This move is called an isolation and is a fairly advanced poi move. I'm not executing it perfectly, but I hope you see the motion that is going on. The obvious question that occurred to me was, why is it that a phase shift of 0 is easy, but a phase shift of 180 is hard? And why is it that there are no phase shifts of 90 or of 45 or of 135 that are reasonable moves with poi? The 801 way of approaching this problem involves rotating reference frames, and it's very messy, very fast. However, the Lagrangian approach offers an elegant way to natively include the constraint of the fact that the poi has a fixed length. Using Lagrangians, I've shown that the motion of a fixed length pendulum under a rotating pivot in a no gravity, neglecting gravity, is in fact equivalent to the idea of holding a pendulum at a fixed position. So, if I have a fixed pivot right here, the pendulum stabilizes around 0 degrees. However, there is, just as with the poi, the 0 degree phase shift was the optimal, was a stable and simple motion to hold. However, there's also another equilibrium, which is unstable, which is 180 degrees from pointing downwards, where the pendulum is tilted upwards. Just as it is possible, but difficult, to keep, through careful motions of one's hand, a pendulum balanced at an unstable equilibrium of 180 degrees, it is possible, but difficult, to keep, through careful motions of one's hand, a poi spinning at a 180 degrees phase shift with its driving hand.